Welcome to our video series on mastering data visualization with Seaborn. Seaborn is a powerful Python library built on top of Matplotlib that simplifies the process of creating beautiful and informative statistical graphics. It comes with high-level functions for drawing attractive and meaningful plots with just a few lines of code. In this series, we will focus on the most important Seaborn plots every data scientist should know. These include distribution plots for understanding the shape of your data, categorical plots for comparing variables across groups, relational plots for exploring relationships between features, heat maps for visualizing correlations and matrix data, pair plots for quick exploratory data analysis across multiple dimensions. By the end of this lesson, you will have a solid grasp of how to use Seaborn to create the right plots for the right questions, enabling clear insights and stronger storytelling with data. Now let's get started. But before, if you are enjoying the video, be sure to like and subscribe for more. For our setup, we will use Jupyter notebooks like we have used in the other videos. And before we start, we should look at our setup and requirements. I assume you already have Python and Jupyter Notebook installed. You should have basic knowledge of pandas, which I covered in my pandas tutorial. Check that, the link's given in the description box. And what we need are pandas, Matplotlib, Seaborn should be installed. And we can do that with this command here, pip install pandas, pip install Matplotlib, and pip install Seaborn. And what we're going to do is we take our command and then we type in pip install pandas. Okay, now it's installed. Pip install matplotlib. That's also installed, and now we can install Seaborn. Pip install Seaborn. Okay, it's also now installed. Now we can go on. Okay, now in our Jupyter notebook, we want to load those libraries. Do this with import pandas as pd, import matplotlib as plt. I forgot matplotlib.pyplot, and import Seaborn as SNS. Okay, it's loaded in. Now I want to talk something about the data we are using today. The dataset compiles heart disease patient records from 4 sources dating back to 1988, containing 76 attributes, commonly reduced to a subset of 14 key features such as age, sex, chest pain, blood pressure, cholesterol, ECG results, etc. and aimed at predicting the presence of heart disease, with the target variable being binary. This means we get a 0 for no disease and 1 for disease. And this dataset is widely used to build and benchmark machine learning models like logistic regression, random forests, support vector machines, etc. for binary classification tasks, distinguishing between patients with and without heart disease. And we're using this dataset to learn Seaborn, to do data visualization, and maybe later on we will also use some machine learning models on this dataset. To find this dataset, you can go to Kaggle. Here's the link in the Jupyter notebook where I've downloaded this dataset. And before we go to the data visualization, we will do a quick data pre-processing to prepare our data. First, I define the file path to the CSV file. Its file equals heart disease.csv. When I read the data, and separator comma. And when we want to view the data, and I take only a sample of 5 random rows. Okay, and here are the results. Here we can see the columns with the features, the row number and the data information. Now let's look at some data information. Do this with df.info. And we can see here are the data types of the columns, and we see, okay, the age is an integer, resting blood pressure, cholesterol, also integers. And we have here some objects, sex, chest pain type. If you look back in our table, those columns are technically categorical variables. So we should assign these data types not as object, but as categories. That's what we do next. So we want data types from object to categories. And we do this by for loop, for columns in our data frame. We select the columns with D types where we have an object, take the columns, and then we assign those columns a new data type, as type, it's called category. Okay, now this has worked. Now let's view again at the data info. And now we can see all those columns where we had object, data type, it's now a category. Now we want to check if we have some missing values, because we also need then to take care of that. Checking for missing values. We take our data frame, then we take, okay, do we have NA stands for missing value, and then we sum up all those missing values, and we see for each column we have 0 missing values. Okay, that's it for the first part. In the next video we will start doing some counter plots or bar plots on the data.